What's up, everybody? Evan here for Grips.com, continuing with Project Get Me Stacking. Today, we are going to cover one of my least favorite subjects in poker, math. And, yeah, it's tough stuff, and it can be a little intimidating, but it is an important element of cards and everything to do with gambling, so although I've been avoiding this Get Me Stacking question for a while, I think it's time to address it. Good day, Evan. Have you thought about doing a video series on expected value and the various formula for working out different common poker situations in a way that your average Joe reader can quickly grasp? There's a challenge, Andrew. And he ain't kidding when he says it. Trying to make this stuff that looks complicated sound easy, it's hard. And it's definitely a challenge. But, you know, my job is to try to teach you guys as best I can from the things that I know. And although I don't use this stuff like all the time, I did do some research on it. I do understand a little bit, so I'm going to do my best to share that knowledge with you. So, if it's complicated, I apologize. I did my best to try to do like expected value for dummies, but if you need me to break it down more or you have questions, just fire away in the comments. This will be a Get Me Stacking that maybe evolves a lot and we get deeper into it, and I'm sure some people will be able to help out with it. But yeah, today we're going to be doing a little bit of mathematics. I know for the most part, Get Me Stacking series has centered around mental game and the game beyond the game, but at the heart of poker, and any card game for that matter, is mathematics. And I want to give a leg up to my less numerically inclined viewers and teach y'all how to calculate a very key element to the game, expected value. This may look intimidating at first if you haven't seen a math equation in a textbook for a while, but I promise you, once you wrap your head around it and get over the actual like labeling of stuff, it's quite simple when you take that second look. So the brackets, for anyone who doesn't know what they are, just means calculate this before you put things together, and for brackets beside each other, you multiply those things. So, why expected value? Why do we care about expected value? Well, expected value allows you to determine A, whether or not a play is profitable or unprofitable, and to what degree. It also, B, allows you to compare the values of various strategic options, i.e. folding versus calling versus raising versus checking versus betting versus re-raising, and it's going to say so on and so forth, but I think that's pretty much all the options that you ever get. So doing this will help you make the most profitable decisions you can, and at the end of the day, it's all about trying to make profit and good decisions in poker. Hopefully, that gets you a little bit excited and will keep you anti-mathers out there from shutting off this episode and going to watch a video of animals with a close-up wide-angle lens. So, to calculate EV, we use the box method where we have boxes. An alternative would be using algebra, and we put values in those boxes and tally the results. Expected value is the combination of the value you get from a result, that's the expected gain or loss, times the odds or frequency of that outcome happening. So how often is it going to happen that I win this much, and how often is it going to happen that I lose this much? Boom, put it together, you have your expected value of a situation. So if you know something will happen 100% of the time, your odds are 100%. Your EV is simply the value of that outcome times 100%, so the value of the outcome. If you know something will never happen, it doesn't matter what the value of the outcome is, the EV is 0 because anything times 0 equals 0. No outcome equals no value. When an event will happen some percentage of the time, And another event will happen some other percentage of the time. That's when we do some multiplication and addition to get the total value. Hopefully you're still with me. We're going to look at the 3 most common strategic options, and I hope that by the end of this presentation you'll understand why pot odds are so important, and you'll just be a tiny bit more excited about math, because understanding this math is going to help you make more money. First, strategically, we have folding. And the value of folding in terms of gain is 0, because you can't win anything from the pot. The odds of that net 0 outcome are 100%, because when you fold, you always surrender the pot. You have no chance of winning the pot. You have no chance of gaining any value. Value of 0 times a frequency of 100 is 0. Keep it simple. Just remember, the EV of folding is always 0. And you guys are like, well, you know, what about like if I raise and someone 3-bet me, I'm surrendering that raise. No, you've already surrendered that raise, because even if you've committed money to the pot, that money is no longer yours. As soon as it leaves your stack, that money is no longer yours. It belongs to the pot. So when calculating EV, you're looking at the decision in isolation. What happened leading up to this point doesn't matter. Next, we have the EV of calling, which is based on how much you can win, what's in the pot, plus the amount you expect to win by calling their bet. So the pot plus their bet, or you can call it total pot. And then you combine that with how much you can lose, which is the amount that you have to call. It's the size of their bet. You then multiply these values by their respective odds of them happening, and then subtract how much you can win minus how much you can lose. So to figure out how often you will win, this is where it starts to get a little tougher. For drawing spots, it's pretty easy. You count your outs and look at the cards remaining, and your odds of losing would be the inverse of that. If you have the best hand, your odds of losing are, you know, your opponent's chances of winning, how many outs they have, and your odds of that's your odds of losing. Your odds of winning is how many brick cards can come on the river. So remember, on the turn card, there's 3 on the flop, 2 in your hand, 47 cards to come. And on the river, there's 46 cards to come. How many of those give you a winning hand? How many of those give you the losing hand? If you're on the river, your odds of calling and winning is based on how many hands in your opponent's range you can beat. And your odds of losing is how many of those hands have you beat. So if you look at the entire spectrum of all the possible holdings that your opponent can have when he gets to the river, how many of those hands do you beat, and how many of those hands beat you? That's how you figure out the odds for the 2nd and 4th boxes in this equation. For more info on ranges, check out my videos on pre-flop play and the triple threat. Notice the key thing. When looking at how much you can win, it's both your opponent's bet and what's already in the pot, because that's what you're going to get if you have the winner. Whereas on the flip side, all you can lose when you call is another bet. You don't lose the value of the pot as well, because that pot doesn't belong to you. Because remember, until it's been claimed, that pot, what's in the pot, belongs to no one. Finally, we have the EV of betting, where one more element is added to the mix. The value you gain by making your opponent fold. This equation may look a bit more intimidating because of the extra brackets and boxes, but it's really no different from the others. I've added one simple element. How's someone going to try to call me while I'm recording a video? Come on now. So all we've added is, you know, the size of the pot times the fold frequency. If you make your opponent fold, you win what's in the pot. So you know the pot size, you know the bet size. That's the easy part. The hard part is, again, breaking down your opponent's range, figuring out what percentage of his calls of his hands he will fold, and what percentage he will call with that you beat, and what percentage he will call with that beat you. Man, that's a lot of percentages, but if you just take the time and map it out on a piece of paper, it's really not that much. Okay, so boom, we know how to calculate all the percentages. They're at the bottom. Just map out your opponent's entire spectrum or range of holdings and then say, okay, this section is going to fold, this section is going to call and beat me, this section is going to call and lose to me. Map out what percentage each one represents. Boom, put them in the boxes, add in the values. You figured out your expected value of making a bet. PokerStove and other equity calculating programs are very useful for this. And the more time you spend doing these sorts of calculations, when you get into spots you're not sure about, the more natural it will become. Now, when I say get into these spots, this isn't something I would expect you to do on the fly, but it's a great exercise to do after you're done playing, when you are reviewing a session and when you have time to work things out. Again, if you practice it, it will become second nature, and that's when you can make these calculations on the fly, but don't expect to be able to do it out of the gate. Math is not easy. Now, for what it's worth, I don't spend much time at all doing expected value calculations, and there are a lot of successful players that barely even know these formulas. The most important thing is understanding the general theory behind them and knowing one of the things that really backs up all decision making in poker, EV. But for the math guys, doing it to the T will definitely improve your decision making and your game. It's just going to make spots like so much easier to suss out what the right play to do is because you know the various values of each. And all you say is, well, the EV of betting is greater than the EV of folding is greater than the EV of calling, I should bet. Whichever one has the highest EV is the option you should take. And you can mess around with how much you bet, but I'm not going to talk about that in this video because that's like an hour. And we try to keep these things to 15 minutes so you can get back to your grind. So yeah, now you know how to do it. But remember, spend the majority of your effort on doing what works for you and suits your learning style naturally, and just spend a minor amount of time on the other stuff. Otherwise you get really tired, but it's important to understand the concept and know about it a little bit. And that is my attempt to break down how to calculate EV. I hope I lived up to the challenge and that I was able to keep it simple enough and understandable that you non-math guys got it. And for you math guys out there, if there's any fine-tuning you'd like to see or you calculate things a little differently, please go ahead and post in the comments. Again, the math part of the game is not my strong suit. I'm really quick at taking a factor and turning it into a ratio and knowing my odds and my equity and my percentage of winning. But in terms of breaking down these formulas and knowing to the decimal how much value each play has, I just don't really do that much. I'm a little bit of a field player. Anyway, if you're enjoying the series and you find you're learning a thing or two, please go ahead and subscribe to the channel below to show your support for my efforts. And if you have any questions for me, please send them on over to evan@grips.com with the subject line, "Get me stacking." Hopefully, I can answer your question and help you get stacking. And that's about it. Please leave your comments, feedback on this video. It is a very interesting topic. And yeah, I hope I did an alright job with it. Please let me know what you thought. And other than that, you guys know what to do. Take what you learned, go out there, get stacking. This has been Evan for Grips.com. Saying peace.